Hello and welcome back to my channel. Let us continue our discussion on one-dimensional Dirac delta function by solving some previous year questions. So let us solve this first question that was asked in JEST 2018. So here our fx is this. Let us put fx equal to 0. Then sin pi x equals to 0 implies pi x equals to n pi implies x is equals to n, and n can take values from 0 to infinite. So 0 plus minus 1 plus minus 2 and so on. Step 1. Now step 2, differentiate fx, that is cos pi x pi. Okay, now step 3. Since these n values all lie within this integer limits, within this x, lie within the integration limit. Now let us put these values here. So f dash 0 equals pi cos 0 equals to pi, as cos 0 equals to 1. Then f dash 1 gives pi cos pi, which is equals to minus pi, since cos pi equals to minus 1. Then f dash minus 1 equals pi cos minus pi, that is pi cos pi, which is equal to minus pi, since cos minus x is equals to cos x. Now we can write this delta function as del x minus 0 upon f dash 0 mod f dash 0 plus del x minus 1 upon mod minus pi, this value, plus del x minus 1 upon f, this one, minus pi, and so on. It's equals, we'll get pi, mod of minus pi is again pi. Okay. After that, we need to evaluate the integral. So I equals to pi from minus infinity to plus infinity, exponential minus mod of x del x upon pi plus del x minus 1 upon pi plus del x minus minus plus 1 upon mod pi, and so on, dx. After that, let us break this integration. E to the power minus x del x upon pi plus pi minus infinity to plus infinity, e raised to power minus mod of x del x minus 1 upon pi dx, and so on. Now we can see this pi gets cancelled out, and from the first one we can substitute x equals to 0 in this. So we'll get e raised to power minus 0 mod, plus from here we can put x equals to 1. So we'll get e minus 1 plus put x equals to minus 1 into this expression. So we'll get minus 1 plus, from here we'll get e minus 2 and so on. Now we are aware how mod is solved, so we'll simply write e to the power minus 0 plus e to the power minus 1 plus e to the power minus 1 plus e to the power minus 2 plus e to the power minus 2 plus and so on. So we'll get an exponential series. Now e to the power 0 is equals to 1. So 1 plus 2 times of e to the power minus 1 plus 2 times of e to the minus 2. Similarly, we'll get 2 times of e to the power minus 3 and so on. Now what we can do, we can combine this, we can take common 2 and we can write e raised to power minus 1, e to the minus 2 plus e to the power minus 3 and so on. So we will get an infinite series. Now we know that the sum of an infinite series is given as a upon 1 minus r, where this a is the first term of the series and r is the ratio between them. So here ratio is what? Let us take the first term and divide it by the, let us take the second term and divide it by the first term. So we'll get e to the power minus 1. So this is the ratio. You can take this one also, e to the power minus 3 and divide it by this term. So you'll get e to the power minus 1. So we know that this is the ratio. So let us find the sum of this infinite series. First term upon 1 minus the ratio, that is e to the power minus 1. Dividing it by e to the power minus 1 will get 1 upon e minus 1. This e will go up and become plus 1. Okay. So this is the value that we get for the series. Now simply put this value here. So we'll get 1 plus 1 upon e minus 1. Now let us solve this thing. So we'll get e minus 1 plus 1 upon e minus 1. Okay, we forgot to take this 2. Let's include it here. Then we'll get minus 1 plus 2 equals minus 1 upon, that equals plus 1 upon e minus 1. Now let us discuss another question that is from JEST 2022. Now here fx is this. So let us put fx is equals to 0. It implies 2 sine x minus root 2 equals to 0. Solving for x, we will get, so 2 sine x equals to root 2. And sine x root 2 upon 2. Let us multiply numerator and denominator by root 2. So we'll get 2 upon 2 root 2, which is equals to 1 upon root 2. Now x equals to sine inverse of 1 by root 2. That is x equals to pi by 4. So we get the xi here. Now taking the differentiation of x with f with respect to x, will get 2 differentiation of sine x is cos x. Now f dash x, x is pi by 4, that is equals to 2 cos pi by 4, and we know that cos pi by 4 equals to 1 upon root 2. Let us multiply again by denominator and numerator by root 2. So we'll get 2 into root 2, and root 2 into root 2 becomes 2. So f dash pi by 4 equals root 2. Now delta 2 sine x minus root 2 can be written as delta x minus pi by 4 upon mod of f dash pi by 4 is del x minus pi by 4 divided by root 2. Now let us evaluate the integration. So I is equals to 100 root 2 upon pi. Integration limit 0 to pi by 2 x, which is our function, del 2 sine x minus root 2 dx. So it can be written as 100 root 2 pi 0 to pi by 2 x del x minus pi by 4 upon root 2 mod of root 2, so we'll get root 2 again dx. Now root 2 is root, cancel root 2, 100 upon pi, put x equals to pi by 4 multiplied by pi by 4, so pi cancel out, 4 times 25 gives 100, so our answer is 25. Now let us see this question that has appeared, that is from GATE 2015. Here our fx is 3t minus 6. So let us put fx equals to 0. So we'll get 3t minus 6 equals to 0. So t equals to 2. Then f dash x becomes 3. So we can write delta 3t minus 6 as delta x minus 2 upon mod of f dash x, that is 3. Now we can see this t equal to 2 lies within the integration limit. So we can evaluate this integration as delta x minus 2 upon 3. So mod of 3 becomes 3 dx. So now we can put x equals to 2 directly into this equation and we'll get t square upon 3. So t square is 2 square upon 3, that is 4 upon 3, which is equals to 1.3. This is the answer. In next lecture, we'll discuss a few more concepts. So thank you so much.